Hello everyone and a warm welcome to this channel. Today we are going to start one of the most important and fundamental topics in digital electronics, the number system. Why is this so important? Because everything in digital electronics or systems, computers, mobile phones, processors, everything works using different number systems. From binary to hexadecimal, these systems from the very language of electronics. So let's dive into the explore them one by one. So when you say number system, it doesn't just mean the numbers we use daily life. So in digital electronics, we deal with different number systems like binary, octal, decimal and hexadecimal. Each system has its own base and it's used for different purposes. Understanding these systems will help you build a strong foundation in logic circuits, microprocessors and many other digital topics. So let's start with the most familiar one, the digital number system. So as you're seeing there, so decimal numbers represents, so we can see that. So basically the numbers, the basic numbers from 0 to 9 that we can able to count. So we can count 3 apples. In the same way, we can also count the other numbers as 5. So there we can see about there are 5 cars. With this all, we can perform all the basic operations like plus, minus, division and multiplication on the basic decimal numbers. Like we can able to add, we can able to subtract, anything we can perform on the decimals. You're seeing there are from 0 to 9. So we can make any digit we want and we can perform any operation we want. It's a simple math we know. But in the binary system, it's not like that. In decimal system, we have from 0 to 9. But in binary system, we do not have any such kinds of systems. But we have only 2 digits or 2 values, whether it is 0 or 1 or high or low. So as completely we have discussed about this binary system in the previous lecture. If you missed that, check out our playlist. And in this video, we will also learn the difference between decimal and binary. And we also know that binary means only 0 and 1s, the combinations of zeros and ones. So it is not meant that if suppose an example, if you see the decimal and binary as 1010, so the basic in binary 1010 is different from 1010 in decimal. So in binary 1010 means 10. So in decimal 1010 means it's 1010. It's both are different. We have to understand that. And the representation of the decimal and the binary and the octal as well as hexadecimal also refers as same as the representation shown below for the decimal and binary. So the representation is same for all. We need to represent because without representing we cannot able to compare both of them. Why it is 10, why it is 1010, cannot able to understand. So in binary it is 2, in decimal we have to write as 10 as a. So see carefully the binary system and the decimal system. So that is, it's all starts with 0. And so the number 1 represents 001. And the number 2 represents 010. So number 3, 011. And so on up to number 7 represents 111. So this representation basically how we can get. So as we all see, so it is basically based on all 2 power n. Starts with 1 and incrementing with 2 power n. So that is the scenario there. So okay, for a simple conversion, so we will consider a number 6. We will be converting to binary and we will check that. So as you're seeing there, so there is a decimal numbers, binary numbers in the table. So we need to convert 6 into a binary format. So basically 6 is a decimal number and we need to convert as decimal. So we need to convert as binary. So we will be starting with 1 and ending with writing 2 power n, like 2 power 1, 2 power 2, 2 power 3, 2 power 4, like that. Means 1, 2, 4, 8, starting with from right to left, going from right to left. So basically, if you add, suppose if you want 6, suppose we are onto 6 means we have to add 4 plus 2, that is going to return us 6. So that the sum of two numbers gives us any required number. So we have to put 1 there and remaining all we should put 0. So that that gives the desired one. So if you take the second example 7, so write the same format from right to left as 1 to 16. And if you want 7, so add up 4 plus 2 plus 1 will give you 7. So write 1 1 1. So that is the decimal format of writing in. So that is the decimal format of writing and binary format. Similarly, the example 10 also. So if you want to write the 10 as binary. So write from 1 to 16 from right to left, then start. So 10 means basically the sum of 8 plus 2. So we need to put two ones there and remaining all zeros. So we will be going to get 1010 as our desired binary number for 10. So this is the simple format of converting a decimal to binary system. So now we also saw the binary to decimal also in a similar way. This is the simple trick or simple way I am saying in this video. As I said, it is a vice versa process. You can also see there, if there is given 110, then you can write 1, 2, 4, 8, 16, and you can add up. Where ones are there, you can add up those decimal numbers above that ones. So 110, above that we have 4 and 2. So add up 4 plus 2, we will be going to get 6. So this is the answer of our decimal number. So same like we have 7, 111, 4 plus 2 plus 1 is 7, and we have 10 also, 1010. This is a simple trick. Now again, in the next slide we are going to discuss with the help of a formula. So basically, what's the formula we have there? So we have the formula. Suppose we have given with 110. So basically that is 6. We need to convert, or we need to find that is the decimal number 6. So that we need to multiply with the as shown in the image. Like that is. So we are converting the 2's decimal into tens suffix. So we are going to multiply with 2 power 0, 2 power 1, 2 power 2, 2 cube, 2 power 4, like that with the individual digit in that, and we are going to add them up. So we are going to get a single digit, that is decimal digit. So the conversion is done this way. So in the same format, we can also convert the fractional part of any decimal of any binary fraction. We can also convert into decimal fraction as shown. But a small problem is there in that. So before the decimal point, we can do simply as same as above decimal. So after the fraction, we need to multiply with every digit with the 2 power minus 1s, minus 2s, and minuses. So we need to add them up. So we are going to get the point after the fractional part, the point after this digits for the binary numbers to decimal numbers. So let us have some look from conversion of binary to decimal. So we are having with 101 by using with formula. So we are going to solve all these with the help of formula. So we can also solve with the help of the shortcut trick also, your wish. So let's see with the formula. So we are going, the first 101 is basically just a digit. So we do not have any fractional part. So we need just going to multiply with 2 power 0, 2 power 1, 2 power 2 with individual digits, and we are going to add them up all. So we are going to get 5. So in the second part, we have fractional part, that is 1101.110. So we are going to multiply with 2 power 0, 2 power 1, 2 power 2, 2 power 3, and with the individual digit, and we are going to add them up all. After the point, we are going to multiply with 2 power minus 1, 2 power minus 2, 2 power minus 3, and we are going to add up all, and we are getting to get a fractional point of 0.75. 0.75 that is going to be added for the 13, the before the decimal point. So we are going to get 13.75. Likewise, the same examples that are given below 001 and 000 as shown with the help of formula. So in the upcoming videos, we are going to see these conversions as well. So the conversions are binary to octal, octal to binary, vice versa. So basically what is meant by octal also we are going to see in the next video. And we are also going to see the hexadecimal, what is meant by hexadecimal, and the conversions between binary to hexadecimal and vice versa also. So the conversions of binary we have seen with octals, and we are going to see in upcoming videos. So these conversions also, those decimal to octal, vice versa, decimal to hexadecimal, and vice versa. So total these 8 combinations we are going to see in the upcoming videos. So stay tuned. So thanks for watching up to here.